Hi kids, this is our video on graphing lines. Now I have a feeling I'm anticipating this one's going to be a little bit shorter than some of the past ones, but let's jump right in and let's start talking. First of all, break out that graph paper, because either you should have your own, as explained in class, or you should have taken some from the stash of blue graph paper that we have in class. Now please use it sparingly, so that means that the part of your notes you're doing with graphing, please do it in pencil, so you can erase and fix it, rather than using up a ton of graph paper that is a limited resource that we have. Okay, so here's the deal. What information do you need in order to graph a line? Well, you're either going to need one of two things. You're either going to need a point on the line and the slope of the line, or you're going to need 2 points on the line. If I can graph 2 points on a line, so if I can graph 2 points on a line, dot, dot, I can draw a line. If I have the slope and a point, I can graph that point and then use the slope as rise and run and give myself more points. And that's what we're going to practice here today. Okay. If I'm graphing a line from slope-intercept form, first thing I'm going to do is plot the y-intercept on the coordinate plane I have. Second thing I'm going to do is use the slope as rise over run to plot 2 more points. Sorry, had to pause there in between 2 and 3 to stop the cat from scratching the couch. Anyway, 3, draw the line all the way across the grid with arrows on the ends. So we plot the y-intercept, we use the slope as rise over run, we draw all the way across the grid, put arrows on the end, and we are done. So we're going to graph 3 lines. And those lines are the red one, A, which is y equals 3x minus 1. This blue one here, B, y equals negative 2/3 x plus 4. And C, this green one, y equals 3/4 x. So we're going to start with A. So we're going to plot the y-intercept. So what is the y-intercept of the line y equals 3x minus 1? Well, based on what we've learned about y equals mx plus b, that's the b value, so that's minus 1 or negative 1. So I'm going to plot a point at negative 1. Now the slope 3, a slope of 3, can be used in one of 2 ways. I can either think of it as positive 3 over positive 1, or negative 3 over negative 1, because both of those give you a positive slope. Negative divided by a negative is a positive, positive divided by a positive is a positive. So from this y-intercept point, from this point I've already graphed, I'm going to use that slope. So I'm going to count up. Rise of 1, 2, 3, and run of 1, and that right there is where I'm going to plot my next point. Right there. Do it again, same thing, rise of 1, 2, 3, run of 1, plot the point. And there's another one. And I can go the other direction. Rise of negative 3, 1, 2, 3, down. Run of negative 1, going to the left one. And then one more. We're going to draw our line all the way across. Please excuse its crookedness. And there you have it. We graphed a line. Didn't have to make a table of ordered pairs or anything. All right, now the blue one. What's the y-intercept of this one? Yep, that's right, it's 4. So we're going to plot 4. Now we can use this slope in 2 ways. Either negative 2 over positive 3 or positive 2 over negative 3. Either way, we will get the correct line. So let's start from the y-intercept. Negative 2 is a rise and positive 3 is a run. So go down 2. 1, 2 down, 1, 2, 3 to the right. And that's the point that we need to plot right there. Do it again. Down 2, 1, 2 over 1, 2, 3, plot the point. Same thing again. Can't fit any more. Go the other direction. Rise of positive 2. Run of negative 3. Going to the left. And we can fit one more. 2, 3, point. Draw the line. Again, please excuse my crookedness. And there we have it. That's the line. Y equals negative 2/3 x plus 4. Now the third one. Now what's the y-intercept here? Positive 3/4 x. But nothing there. What could I write there and not change it? That's right, I could write a 0. So I'm going to go ahead and plot my 0 and use my slope of 3/4. Rise of 3, run of 4, point. Rise of 3, run of 4, point. Count carefully. All right, can't fit any more that way. Rise of negative 3, run of negative 4, point. Rise of negative 3, run of negative 4, point. Arrows on the end of our line. Oh, I didn't do a good job of that. Let's try that again. Well, hold on. I just have to make it longer. That's all. Ooh, so messy. But you understand how to do that, I hope. Let's move on. Now you're probably asking yourself, but Mrs. LeCompte, what if the equation isn't in slope-intercept form? Well, that's easy. What you're going to do then, if that's the case, is you are going to solve for y. Because then it will be in slope-intercept form. Let's try a couple together. Okay, here's your first one. All right, so this one is, remember, this is like solving a literal equation. Now, I don't want to hear you start saying, oh, I suck at those. Well, that's all well and good, but you know how to do this. It just takes focus and concentration and remembering the rules of solving an equation. So really, we already know how to do this. So what am I going to do to solve this for y? Well, I need to get rid of the 4x first. So I now have 2y equals. Now this comes back to something I showed you earlier in the year. I would much rather see negative 4x plus 6 than 6 minus 4x. And now we're going to see why I'm going to be that particular about it. Because once you go ahead and you finish solving that for y, if you have it with the x value, the linear term, first, it's called the linear term, this one right here, linear term. If you have that first, once you finish solving for y, it's already in the y equals mx plus b format that we're used to, and we're ready to use it to graph. Awesome. I'm going to give you another one. I want you to do it. 3y plus x equals 6. I want you to solve this one for y. So go ahead and pause your video and do that. And I'll do it as well. All right, so I'm going to get rid of the x. I'm going to divide by 3. Now how am I going to write that? Again, this comes back to things we've looked at quite a bit lately. Remember that negative 1x over 3, I can pull that x off, and that negative 1 over 3 is the coefficient of x, and in this case, it is the slope of the line we are graphing. So those are the two lines we're going to graph, and we're going to use the colors you see underneath them. And let's graph. So let's start with the red one. Y-intercept of, and again, pause it, try it yourself, come back. Y-intercept of 3, positive 3. Slope of negative 2, so that's either down to right 1 or up to left 1. Down to right 1, down to right 1, down to right 1, and all the way to the end, up to left 1, up to left 1. Oop, hey now. Make sure we can actually graph it neatly. Point. And there we go. Not bad at all. Now the blue one. Slope of 2, y-intercept of 2, slope of either down 1, right 3, or up 1, left 3. So, down 1, right 3. Oh, so these are both downhill lines, both negative slopes. Up 1, left 3, 1, left 3, up 1, left 3. Draw your line all the way up to the ends. Arrows. So it doesn't matter whether it's given to you in slope-intercept form or not. You can put it there. All right, let's look at some other strategies for graphing. You can graph a line using intercepts. You can find the x and y intercepts of a line by plugging in 0 for y and x respectively. So you plug in 0 for y, finds you the x-intercept. Plug in 0 for x, finds you the y-intercept. Plot each intercept on the graph, and then you're going to draw the line all the way across the grid just like we did before. All right, let's try it. And here are our two examples. Okay, so we're going to start by actually finding the x and the y-intercepts. Now remember that you're plugging in 0 for the other coordinate. So to find the x-intercept, wrong color. To find the x-intercept, I would plug in 0 for y right here. And so that would give me 3x equals 12. And that means x equals 4. So I have an x-intercept of positive 4. But for the y, I would plug in the 0 over here for x, leaving me negative 4y equals 12. Dividing by negative 4 would give me y equals negative 3. Excuse me, and there we have our line. Now I can draw the line that connects those 2 points but I'm also going to go ahead and plot any other points I can see using my rise over run slope definition. So there's another one there. And all I did was go from one point to the next. It was up 3 and over 4. 3, 4. Yeah, I did do it right. Awesome. Let's do the other one. Again, as we usually do, pause it, try it yourself, see what you do on your own. All right, x-intercept is 7 1/2. I'm going to plot it right there. Y-intercept is, by coincidence, sheer coincidence, I totally just made these problems up, it's -3. So let's look at the rise and the run there, just like the red line. The rise and the run. So that's up 3 and over 7 1/2. A little awkward, but it'll work. And I'm just going to go ahead and draw my line. Oh, I violated my own rule again. Got to keep that going all the way out to the edges. So in class, use a ruler. It's going to make things a lot easier. But you'll notice having that decimal for that x-intercept, not any more complicated necessarily, because we can just graph the decimal value 7 1/2. It's just halfway from 7 to 8. But it does make finding that rise and run a little bit tougher if I wanted to find more points that way. Next up, we're going to jump into some application problems. I liked this one. It was an example in the textbook. I thought it was cute. So you've got the diver here. Water pressure can be measured in atmospheres, ATM, and we use the information in this diagram over here. We're going to write an equation that models the pressure Y at a depth of X meters. So the pressure you're feeling at a depth of X meters. And then we want to graph that pressure. So we're going to do the graph on the following page, but we've got some information here that's going to help us. We know that the pressure increases by 1/10 of an ATM per meter, and we know that the pressure at 0 meters is 1 atmosphere. Okay, so we need to write an equation. So Y is the pressure. So Y, it would help if I actually had a pen tool. There we go. Y equals the pressure, and it's changing per meter, and it's starting at a pressure of 1 atmosphere. So we actually have both the slope and the y-intercept here. At 0 meters, the pressure is 1 atmosphere. So that is basically saying that if x is 0, y is 1. That to me looks like a y-intercept. That's the number that goes in the y-intercept spot, 1. And what's the rate of change of that pressure? Well, the rate of change of that pressure is 1/10 of an atmosphere per meter. And rate of change is the same thing as slope. So there we go. There's our equation. Y equals 1/10 x plus 1. And on the next slide, we're going to graph it. All right, y equals 1/10 x plus 1. How exactly are we going to set up the coordinate grid for this? Well, each of these lines on the bottom, let's make each of those count by tens. So this one would be 20, 30, this one would be 40, 50, 60, and so on. And then over here, let's have this count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that would be 10 all the way up there. But we've got the point. This side is pressure in atmospheres, and this side is depth in meters. Sorry, I know it's way on the bottom there. All right, so the y-intercept is 1, and the rate of change is 0.1. Now that is going to be difficult because that's 1/10, 1/10. So a rise, well, if I think about it in terms of a fraction, it's a bit easier then, isn't it? A rise of 1 and a run of 10. Now be careful, because we counted differently on these axes. Oop, I switched colors by accident. We counted differently on these axes, and I know you're probably saying, well, you told me not to do that. With a consumer application, it's a little bit different. We're comparing two things that are not related on a one-to-one basis. A depth of 10 meters, okay, gives you a change of the pressure of 1 atmosphere. So when you count rise and run, a rise of 1 is going to go up 1 notch, 1 unit, and a run of 10, so a rise of 1, run of 10 is only going to go over 1 unit on the y, on the x, because we counted by tens. So rise of 1, run of 10, but it really looks like a slope of 1. That's one reason why I told you guys to make sure that you went ahead and put for regular old graphs that aren't consumer applications, go ahead and put the same unit on each side, or the same unit of, same numbering, I should say, on each axis, on the X and the Y. But when it's a consumer application, it's a little bit different. All right, and there's the graph that relates the pressure as it changes with the depth. And that's going to conclude tonight's video. Hope you enjoyed it. We're going to be doing some graphing in class, so, bring your graph paper, or don't, whatever. I have some. But that's what we'll be doing. So I will see you guys in class.